Bismillahirrahmanirrahim. Assalamu alaikum. My name is M.Asif. Welcome to my channel, M.Asif's Math Corner. We will study about group theory today. It's my first video. Inshallah, I hope that you will learn more about mathematics in my this channel. So let's start about group theory. Today we will study that which non-empty set we can say that it's a group, which are the conditions that should follow. So let's start. Group. A group, a pair G steric where G is a non-empty set and steric is a binary operation in G is a group if and only if. We will discuss that when a non-empty set is called a group, which condition should be valid, which condition should follow. The first condition or the first property is closure law. The binary operation steric, i.e. A steric B or B steric A, for all A comma B belongs to G. It's mean that if we take a non-empty set and we take any two element of that set and operate by the given operator, if the answer is also belong to that set, then it is closed. For example, let's take a set A is equal to 0, 1, 2, 3, which belongs to real number, and we take any two elements 2 and 3 and operate by the given operator. The operator may be of multiplication or may be of addition. 2 steric 3 means if the operator is multiplication, then 2 multiplied by 3 is equal to 6, and we know that 6 is also belong to real numbers. And if the steric operation is addition, then 2 plus 3 is equal to 5, and we know that 5 belongs to real number. It means that this set is closed. The first property hold. If the closure law hold, we have a unique name for it, that is groupoid. That is groupoid. If any set is closed, that is called groupoid. The second condition is associative law. If by any binary operation, if associative law hold A steric B steric C is equal to A steric B steric C for all A, B, C belong to G, if any three elements of a non-empty set give us the same answer by using associative law, A steric B steric C is equal to A steric B steric C. In common, the associative law hold about all of the groups we studied. If the associative law hold and the non-empty set is closed, we say that it is a semigroup. So the third condition is identity. Identity element is a unique element, and with respect to addition, identity element is 0, and with respect to multiplication, identity element is 1. For example, we have a number 2, then we add which number to 2, then the identity of 2 still exists. For example, 2 plus 0 is equal to 2, 3 plus 0 is equal to 3, 10 plus 0 is equal to 10. It means that the additive identity is 0. Similarly, the multiplicative identity is 1. For example, 10 multiplied by 1 is 10, 100 multiplied by 1 is 100. It keeps its identity by multiplying by 1. So, in general, we say that E is an identity element in G. In that non-empty set, identity should exist, and identity should be the unique element. There is no other element which we call identity. So we write it A steric identity is equal to identity steric A is equal to A. For example, we discussed the multiplicative law, or the steric operator is multiplicative operator, then E is equal to 1, and for example A is equal to 2, so 2 multiplied by 1 is equal to 1 multiplied by 2 is equal to 2. If these three conditions hold, then we say that it is monoid. It has a special name, monoid. Monoid mean any non-empty set that uh, that is closed, that associative law hold, and that has identity. And the fourth condition is inverses. The inverses of element, every element should exist. For example, we have the set 2 3 4 5, then all the 2 3 4 5 all elements should exist in their inverses. The additive inverse of 2 is, we know that, minus 2. So if 2 is in the set, so minus 2 must belongs to that set, if we are discussing with the operator with respect to addition. If with respect to multiplication, we discuss that if 2 belongs to G, then 1 by 2 should also belong to G. This implies that the multiplicative inverse of 2 is 1 by 2, 3 is 1 by 3, 100 is 1 by 300, A is 1 by A, and additive inverse of 1 is minus 1, 3 is minus 3. So we can write A steric A inverse is equal to A inverse into A is equal to identity. It should give us the identity element. It means that we know that multiplicative identity is 1. So the multiplicative inverse of 2 is 1 by 2. When we multiply 2 multiply into 1 by 2, we get 1, and that is multiplicative identity. A inverse is called the inverse of A in G, and it is denoted by A inverse. So as these four properties hold, that non-empty set we can call that a group, that is a complete group. So we came to know that for a group, at least four properties should hold. First, that non-empty set should be closed. Second, associative law hold. Third, that non-empty set should exist a unique identity. And fourth, that non-empty set, every element of that non-empty set should its unique inverse. Next, we have abelian group. A group G is abelian if its binary operation is commutative. If the commutative law hold, A steric B is equal to B steric A, then it is also called, it has a special name, abelian group. This is the fifth property, and we put it at the fifth number because first four show that it is a only group, and the abelian group is an additional property of groups, and if the commutative law hold, it is called an abelian group. Next, in next lecture, inshallah, we discuss some examples, some common examples which we study everyday life, that those groups are those sets are groups or not. Thank you so much. Please subscribe my channel if you like it.